I've seen a lot of people overcomplicate electromagnetic radiation. And I mean, when you really dive deep into it, it does get really complicated. But what I'm talking about is people will overcomplicate the very basic idea of electromagnetic radiation. Like with microwaves, X-rays, radio waves, and all that, people know what they do, but how they do it is still borderline magic, and people can't really picture it in their mind. Sometimes when you hear terms like electromagnetic energy or magnetic field, your brain will start to go into autopilot, or maybe you'll just start to zone out because you're not used to hearing those terms on a day-to-day. And that's fine, because that's what my brain does too. Whenever I'm trying to learn something new, if you start throwing new words at me, I'm gonna start zoning out. That's just how I am. But I think this is worth learning about because it's just so much of our every day-to-day life, and it's just really cool to know about how stuff like Wi-Fi and Bluetooth and FM radio, how all that stuff really works. So the goal of this video is to give you a sort of intuition for what electromagnetic radiation actually is, so you can imagine it, so it seems less scary, right? So in this video, no math, no formulas, at least for now. I tend to oversimplify stuff in my head, so my goal here is to give you my sort of oversimplified perspective, so that way you can take that, and whenever you go to watch a YouTube video on a subject or you go to read an article about it, it's easier for you to imagine. If you've ever been to the subreddit Explain It Like I'm 5, then you probably know what this is. This is basically an Explain It Like I'm 5, but from the perspective of someone who only really understands things when they're explained in that way. All right, so let's start here. Here we have the electromagnetic spectrum, and it is beautiful. Now, you've probably seen this sort of diagram before, and usually when you see it, you'll notice that the visible light portion of the spectrum is kind of highlighted, or it stands out in some way, because obviously that's the part that we're all the most familiar with. But despite the fact that this is all just one long spectrum, with visible light just being a part of it, people still get confused. People still have this urge to consider visible light something totally different from the rest of the spectrum. And I know this because I had to go through school for this thing, and people would have a hard time imagining it or picturing it in their minds. And because people had a hard time picturing it in their minds, they would have a hard time understanding what it would do in a situation they've never encountered before. And I think the thing that messes people up the most is probably just the language that we're using to describe all this. So here's what I want to make perfectly clear. Every day when you and I use the word light, what we're referring to is obviously visible light. But we could just as easily use the word light to describe the rest of the spectrum. In fact, we kind of already do this, but we only do it to some parts of the spectrum. No matter what part of the spectrum you're on, we're really just talking about invisible light. Sometimes we call infrared radiation infrared light, and sometimes we call ultraviolet radiation ultraviolet light. So what's stopping us from calling X-ray radiation X-ray light, or microwave radiation microwave light? Light is light whether we can see it or not. And when you're going through school or you're reading it out of a textbook, you'll hear that radio waves move at the speed of light. And well, that's because that's what it is. So try to imagine it with sound and like a dog whistle, for example. When you blow on a dog whistle, you know it's making a sound. You can see a dog's reaction to it. But you know the only difference between that sound and any other sound is our ears aren't tuned to hear it. But you're not gonna think that that sound is something totally different from other kinds of sound, right? It's still sound. Sound is sound, but people don't want to think of something as mundane as light and lump it with things like gamma radiation. But that being said, if someone says to go turn off the light and you go and turn off the Wi-Fi router, you're just kind of being a jerk. So technically, as long as we have a clear understanding of what visible light is, or at least on how it acts and what's actually happening, we should have a pretty clear understanding of the rest of the spectrum. So let's do that. Let's make sure that we understand visible light. And specifically what I'm talking about is, let's make sure we understand how vision works and how colors work, and then we can just kind of apply that to the rest of the spectrum. And like everything else, this is going to be a pretty in a nutshell explanation. I'm not going to overcomplicate anything here. All right, so let's talk about vision for a second. And if you know how vision works, stick with me for a moment because I have a point to make with all of this, but let's just make sure we get a quick down and dirty rundown of how it works, okay? I'm holding up two sheets. One is a sheet of foam. It's white. It's opaque. I can't see through it. And the other is a plastic sheet that I can see right through. Well, what makes something transparent versus something else being opaque? How does that work? Here I have two more sheets. Now they're both sheets of foam. They're both opaque, but one of them's red and one of them's blue. Well, how does that actually work? I mean, if you stop to think about it for a second, how does it actually work that two of the same material are completely different colors? Or, I mean, I guess what I'm asking is, what are colors? Like, why? What are colors? Why are colors? One of those. I'm asking one of those. And it might seem mundane, but you know, it's got some pretty far-reaching consequences. And the answer to both questions is it all has to do with how the different frequencies are interacting with the different material or pigment in question. And I'm about to simplify that in a moment. But before I simplify that, let's go back real quick to that electromagnetic spectrum. I want to take another look at it, but specifically what I want to look at is the visible light portion of the spectrum. So the cool thing about the visible light spectrum is that we can see the difference in frequencies through a change of color. So when the electromagnetic radiation hits our eyes, our brain does some sort of signal translation, and then we process that as different colors. At the bottom of the spectrum, we have red, which is easy to remember because right below red, we have infrared or below red. And at the very top, we have violet, and that's easy to remember because right above violet, we have ultraviolet. And by the way, when I say top and bottom, I mean, usually we describe frequency by the We usually describe light by the frequency. Sometimes we'll describe it by the wavelength, but usually we describe it by the frequency. And the lower left on this picture that you go, the lower the frequency gets, right? And as you move up through the visible light spectrum, as you increase the frequency, you increase the color to our eyes. And if you're like me, you might be wondering what that actually means, like what it means for there to be a frequency to the light, or maybe you've heard that before, but you're a little confused on what that actually means. Like, what does it actually mean for light to have a frequency? What's actually oscillating? What does that look like? We'll get into that in another video. But for now, we'll just remember the frequency. We'll just keep in mind that light has a frequency, okay? Okay, well, that's all well and good. But the other thing I really want you to pay attention to is the fact that there is no, do not get distracted. The other thing I really want you to pay attention to is the fact that there's no white on the spectrum. And that's because white and black aren't really colors. And it's also because what we see as white light is actually all of those frequencies of light kind of getting shown at once, as if they're sort of blending together into one big beam. It's basically what you get when you mix all the colors of light. That just happens to be how our brains perceive it. So a white light bulb isn't just making a single white frequency, it's making a whole range of colored frequencies that we just process as white light. And that may be important to remember for later when we're talking about other technologies that make more than one frequency at a time, which is probably most of them. And if you need proof that white light is all of those colors at once, well, just take a look at this beautiful cover album by Pink Floyd. It's right there. So with that in mind, let's take a look at what's actually going on with the first two sheets that I showed before. Remember, that was the white sheet and the clear sheet. So here we can see what's actually going on. So let's take a look at this. So with the white sheet, you can see in the diagram that all of the colors are getting reflected right off of the sheet. So remember I said that white light is actually all the colors being shown at once. So you can think of that, this diagram as representative of a big white beam. So all of the colors are getting reflected off, and then eventually those reflected colors or frequencies will make it back into your eyes, and you'll see the sheet as white. Okay, that's simple enough and straightforward. So what's going on with the transparent sheet? So with the transparent sheet, the light is getting shown right through the sheet. It's almost ignoring the sheet completely. And then that light gets bounced off of me and then into the camera or into my eyes or wherever the final destination of that light happens to be. Okay, that's straightforward enough. You might have already known that, but that's what it means for something to be transparent. Let's move on. So here we have a demonstration of what all the colors are doing, and it's basically the same thing. We've added the black, and the black is straightforward. The black is just all of the colors getting absorbed instead of reflected. Okay, straightforward. And then with the red and blue sheet, you can see that it's absorbing most of the colors except for the colors around whatever that frequency or whatever that color happens to be. So for example, the blue sheet is absorbing all the colors except for the blue. It's reflecting the blue off, and same idea for the red. All right, that was a lot to explain, and you might have already known that. You're probably wondering what any of that had to do with wireless communications or radio or Wi-Fi. Well, one of the key concepts that I'm trying to get across is that, actually, let's go back to that spectrum real quick. So one of the key concepts that I'm trying to get across is that as you move up and down this spectrum, well, think about it with the colors first. As we move up and down the frequencies in just the visible light in just a color spectrum, what frequencies will get absorbed and what frequencies will reflect, that's constantly changing, right? Well, the same is true for the entire rest of the spectrum. As you move up and down the spectrum, what the light will treat as reflective or transparent or refractive or whatever, that's constantly changing. And that's one of the main considerations for how any specific frequency or range of frequencies might be useful to us. So, I mean, we've already seen the examples with the visible light, but let's take X-rays, for example, because that's a really obvious one. So X-rays, what are X-rays really when you get right down to it? I'm talking about the ones that you encounter when you go to the doctor's office. X-rays are just light, like any other light, except it happens to be light that is in such a nice sweet spot that it happens to treat our skin as transparent, but not our bones. So an X-ray like this one is really just a big beam of X-ray light being shown onto our bodies. And then what you're seeing here is just a shadow of that. And I think that's really cool to think about, that it's really that simple. It's not like, X-rays aren't magic, and it's the same with everything else on the spectrum. Another application you might have seen is with your Wi-Fi router, because maybe while opening your router, you saw in the box, or while messing in the settings, you saw that there were two signals. There was a 2.4 gigahertz signal and a 5 gigahertz signal. Probably. Most routers nowadays come with both signals. And there are a few differences, but one of the main considerations that you should think about when you're thinking about which one do I connect my devices to is, well, how many walls am I going through? Because the 2.4 gigahertz signal does a better job of going through walls than the 5 gigahertz signal does. If we could see both of the signals, the 2.4 gigahertz one would be treating the wall as more transparent versus the 5 gigahertz signal one. And there are other things to consider, like the 2.4 gigahertz signal one does have a higher likelihood of getting interfered with from your other appliances. We'll get into that in another video. But my whole point in all this is these are the basic things that you need to know if you want to understand why do we use a certain frequency for this purpose versus that purpose. Practicality wise, why is this frequency more useful for this versus that? Laws, why did we choose to use this part of the spectrum for this versus that? This goes a long way into understanding all of that. And if you think of electromagnetic radiation in those terms that we just described, it goes a long way into understanding everything that you read or that you watch that is talking about electromagnetic radiation. It starts to make a lot more sense, and you can actually imagine it in your mind. Now, there is a lot more to learn about, but these are just the very basics. I'm going to go through as much as I understand, which admittedly might not be that much. But in the next video, we're actually going to talk about what makes up a wave, like what makes up a radio wave or a light wave. Now, I don't want to go too deep into any of these videos, right? I only understand this stuff so much. But what I also don't want to do is just say that, hey, light has a frequency. Hey, light has an amplitude. Hey, light has a magnetic field. Knowing those things isn't hard. It's understanding them, like picturing it in your mind, actually understanding, making sure you even know what an electromagnetic field is, or what a field is for that matter. Because to be honest, that stuff is never explained. It's just kind of thrown out. So all of this stuff will be kept very simple, but I also don't ever want to leave you hanging as far as just believe me, light has a this or light has a that, okay? That's all for this video. I hope this helped you gain a little bit more confidence in this topic, because I honestly think that electromagnetic radiation and radio and Wi-Fi and Bluetooth, I think all of it is really cool, and I hope that that came across in this video. So thank you for watching, and adios.